Hi there, ladies and gentlemen, boys and girls, and kids of all ages. This is Miss Rickfelder, and today we're going to be looking at ratios and rate problems. This is going to start on textbook page 72 and go through textbook page 74. Remember, if I write it on the screen, then you write it in your textbook in relatively the same place. These notes do not go in the composition notebook, so they should be going in your textbook directly. Today's lesson is brought to you by this cute little guy right here. He just insisted on sitting on my lap today, so I figured I would take a picture and share it with all of you. Everybody all together now. Aww. All right, let's get started. You want to make sure that you have your headphones on if you're in a noisy location, but if not, if you're in a quiet location, then you can go ahead and just listen freely. Your textbook, because you need to write in it. Notice there are colored pencils and a regular pencil, so you can't write in highlighter, marker, or pen in your textbook. So make sure if you want to use colors that you're using your colored pencils. So let's go ahead and check out textbook page 72 now. Everybody make sure you're on 72. At the top it says solve ratio problems. All right, so now we're looking at a zoomed in feature here. We've got solve ratio problems. You can use a bar diagram or equations with equivalent ratios to solve ratio and rate problems. It says Heritage Middle School has 150 students. 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. So let's first, before we continue on reading the rest of this problem, let's go ahead and annotate what we have. So some pretty important information that they gave us here. It says 2 out of 3 prefer gel toothpaste. So let's go ahead and get that boxed in blue. And they also told us that there were 150 total students. So all of that is important information. It says use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So the first thing you want to do is draw a bar diagram. Even though they've already drawn one for you, I want you to go ahead and draw your own. So you can even draw it right down here. So you're going to draw your own little bar diagram, and you want to remember excuse me, that the whole bar has to represent 150 students. And actually, I went ahead and moved it over here to the left. You can keep it wherever you'd like it, but just make sure that you have some room to write. So this whole bar diagram has to represent the 150 students. Now remember, the ratio for the class was 2 out of 3. So that means because we see the words out of, that means it's sort of more like a fraction type ratio where there should be 3 chunks. So we're going to first cut this into 3 chunks. So that's relatively 3 chunks. And then we're going to label each chunk. So what you needed to do was divide 150. So let's do that off over here. So we've got 150 divided by the 3 chunks. And again, that 3 came from right there. So 150 divided by 3 gives you 50. So that means there should be 50 students in each chunk. Then you want to start labeling your diagram. Go back to the problem. It says that 2 out of 3 prefer gel toothpaste. So now you want to put a bar around 2 of them. So these 2. So you can say gel toothpaste. And that next little bracket is going to be not gel. Okay, so you want to make sure that you remember, first you draw the whole bar, then you want to make sure that you know that number at the top, the 150, and then you want to split it into whatever the ratio portion is. So now we can solve the problem using the bar. So it says, use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So here's the thing too, you have to make sure to read the question. So now since the question says how many prefer gel toothpaste, that's going to be these 2 chunks right here. So 100 students is going to be your answer using the bar diagram, because 100 students in the whole middle school would be a 2 out of 3 ratio. Now we're going to look at method 2, using equivalent fractions. So first we need to make sure that we set it up just like we saw in the problem. So go back to the problem and see it was 2 out of 3 prefer gel. So first we're going to set it up to look sort of like a fraction. So just like they've done in the picture, you want to find a spot on your paper so that you can write gel 2 out of 3 total. Now make sure that you don't make the mistake and say gel to not gel, because that wouldn't be correct. It's 2 out of every 3. So now you're going to write an equal sign. And now we're going to have, because they told us that the total amount of the students in the school was 150, we're going to go ahead and write that 150 right here. And then that's the total for the school. So now we're going to ask ourselves, how do we get from 3 to 150 using multiplication or division? Well, to get from 3 to 150, we can multiply by 5, 0. 5 times 3 is 15, and then add the 0. So whatever you do on the bottom, to the bottom of the ratio, you have to do on the top. So we're going to multiply the top by 5, 0. So 2 times 50 is going to give us 100. And so now we know that 100 students would prefer gel. So you can use either of those methods to solve the problem. You have the bar diagram method here, and then you have the equivalent fractions method right here. All right, let's look at example 2. This example is a little bit different because I want you to think and remember that this example says 2 out of 3. So this is an out of example. So again, let's draw some attention to that. Just make sure that we know out of. That's really important because it's a different bar diagram now when we're looking at this one. And the reason being is because the problem says the ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. Now that's important, 3 to 4. Let's go ahead and write that right out here, 3 to 4. That's different than 3 out of 4. Remember, 3 to 4 means 7 actual messages, 3 from Lucas and 4 from his sister. So let's go ahead and label that. All right, so I changed up the colors a little bit so that we could match them to match Lucas and his sister. But notice I've also written a little star here that says 7 messages in this ratio. So in this ratio, when it was a 2 out of 3, you only had 3 for your total, period. That was it. But in this ratio, when it's 3 to 4, because it says 3 to 4, what it's saying is that for every 3 Lucas sends, then 4 his sister sends. So that's a total of 7 messages. So now we want to draw the bar diagram as well. Even though we already see it, we're going to still draw it anyway. So I'm going to draw mine down here, and then I'm just going to separate it. Now it says Lucas sent 18 text messages. So let's go ahead and underline that. So Lucas sent 18 text messages. How many text messages did his sister send? So this is, again, a little bit different of a problem. So remember how I said that you had 7 messages total. So for every 3, then there were 4. So let's go ahead and break our box here, or our bar diagram, into 7 total boxes. So 1, 2, 3, 4, 5, and 6 should give us 7 boxes. All right, so now that we have our 7 boxes, we know that 3 of them will be for Lucas. So these 3 will be Lucas. And we know that 4 of them will be for his sister. So these 4 will be for his sister. Perfect. Now what we want to do, they said that Lucas sent 18 text messages. So let's think about that. If these 3 blocks right here are for Lucas, we need to take 18 and we divide it by the 3 blocks that he has. And then that means that 6 messages go in each one of those blocks. So now that we figured that out, let's go ahead and put 6 in here, 6 in here, and 6 in here. So that covers us for the 18 that Lucas sent. Now, because each of these is going to be even, let's go ahead and add 6s to the other blocks. 6, 6, and 6. So now we can use this information to find out how many text messages his sister sent. So now we're going to bracket this in and we're going to count 6, 12, 18, 24. So that means that his sister sent 24 text messages. And we found that out by taking the 6 in each block, multiplying it by the 4 blocks that we have, and then we get 24 messages. So now let's go on and look at method 2. Textbook page 73 is where you're going to find method 2. And for method 2, let's go ahead and take a look at it. It says to write an equivalent ratio, use equivalent fractions. So as they've done here, you're going to rewrite this. If you need to add line stickies, you can do that. All right, so now I've set it up just like they have up there. And now we're going to plug in the information they gave us about Lucas. They told us that Lucas sent 18 text messages. So just like we did before, we're going to figure out that relationship between 3 and 18 because those are the 2 numbers that we have to work with. So 3 times 6 gives us 18 because we need to think, what times 3 would give us 18. And then 4, we have to do the same thing on the bottom. So 4 times 6 would give us 24. So both methods are appropriate and you find the answer of 24 text messages with both methods. All right, so now you're going to go ahead and pause the video and you want to try this got it problem on your own. Don't forget to annotate the problem as you're working it out and then write some notes off to the side. All right, great, welcome back. Let's go ahead and take a look. So it says in a survey, 4 out of 5 people, so as soon as I read that, I'm gonna start annotating here. So we've got 4 out of 5 people preferred creamy over chunky. So before I do anything, I'm gonna just go ahead and pull this information out and write it over here. All right, so as you can tell, I left the bottom part open because I want you to first make sure that you don't make a common mistake. So you could totally have read this and gone, okay, creamy on top, chunky on the bottom. But the most important thing in this entire problem that you can make an error on here is this out of. Remember, out of means whatever they're talking about, so in this case creamy, to the total. So we need to make sure to write total here. So that's a different kind of ratio, remember? So on the bottom over here, we're also going to write total, okay? Now it says there are 120 people shopping at the grocery store. So would that go for the creamy part? Do 120 people like creamy, or would that go for the total? That would go for the total. So we're gonna write 120 down here. And then it says, and so we are gonna annotate that as well, 120 people. Use the survey to predict how many people in the store would prefer creamy peanut butter. Now keep in mind, they can ask you, I want you to make sure that you remember this, they could have asked you, use this ratio to predict how many like creamy peanut butter or how many like chunky peanut butter. Make sure that you remember that. But they asked you about creamy. So now let's go ahead and figure that out. So to get from 5 to 120, you're gonna have to multiply by something. So let's go ahead and divide it out down here. So you get 5 times 2 is 10, 2 left over, and 5 times 4 is 20. Perfect. So now we know that we multiplied by 24. So let's go ahead and write multiply by 24 here. And you guessed it, we're gonna write multiply by 24 here as well. Ooh. So now you probably won't know 24 times 4 right off the top of your head, so make sure somewhere on the page you're doing the multiplication. 4 times 4 is 16, 4 times 2 is 8, plus 1 is 9. So now you know that you get 96 up top here. So then our answer is 96 people would prefer creamy. Now I'm also going to make a little diagram here to show you what it would look like. I'm going to erase this work, so you don't need to erase the work. I'm just erasing it so that I've got some space here. So I'm going to make a little bar diagram so that you can see if you used a bar diagram, then you can see if it was correct. So first I start with my whole bar, and then I need to break it into pieces. So now we need to go back to that ratio and find out, was this a part to whole, meaning like the total, or was this a 4 to 5 where we have 9? So this says 4 out of 5, so that means I need 5 boxes. So I've drawn 4 lines so that I would have 5 boxes. Now it says that 4 out of 5 prefer creamy, so I'm going to go ahead and put a little bracket here, and this is my creamy. So then that means that this one over here is going to be my chunky. So now since I have 5 boxes, this is where that 120 divided by 5 comes in. So now I know that there are actually 24, the number 24 goes in each block. So let's go ahead and write 24, 24, 24, 24, and 24. And now we're going to do the same thing that we did before, and we're going to go ahead and add up these 24s. So you can see you have 24 times 4 here, and we get that same answer of 96 people. So you want to make sure that you have the 96 people, regardless of whether you use the bar diagram or the equivalent fractions. Now you want to try B. It says a survey found that 12 out of every 15 people. So right away, I'm going to annotate the problem. 12 out of every 15 people in the United States prefer eating at a restaurant over cooking at home. So we have restaurant and cooking at home. If 400 people selected eating at a restaurant on the survey, how many people took the survey? So let's go ahead and set that up first as equivalent fractions. So remember, this is 12 out of every 15. So again, this is going to be a part to whole problem. So we do 12 out of 15. And it says restaurant. Let's go ahead and do restaurant. And let's write home here. Equals. Then it says, oh, I'm sorry, scratch that. Totally made a mistake. Restaurant, hold on, made that common mistake. Total, not cooking at home, total. Make sure you fix that. That was my bad. All right, and then you want to look back up in the problem. It says 400 people selected eating at a restaurant. So that means that the 400 has to go on top because remember, we have to match it with where it is in the problem. So since restaurant's here, restaurant has to go here, okay? So let's go ahead and put that there. And then it says how many people took the survey. So that would be the total. So now to get from 12 to 400, we have to figure out how to divide that. So once you start dividing it out, you come to the conclusion that it's probably not going to work out nicely. And so since we're talking about number of people here, let's think about a different strategy. So I'm going to go ahead and erase this. All right, there we go. So now when we have this 12 to 15, can we reduce this to another number? Sure we can. We can divide both the top and the bottom by 3. So let's take our 12 to 15 and let's divide by 3. Now I have a ratio of 4 to 5. 12 divided by 3 is 4 and 15 divided by 3 is 5. So now I can use this 4 to 5 ratio, 4 to 5, restaurant, total. Now I can work with this, equals 400 for the restaurant. This is pretty easy to see the relationship, right? To get from 4 to 400, now you're going to multiply by 100. So to get from 5 to your answer, you're going to also multiply by 100. 5 times 100 is 500. So now you know that 500 people took the survey. All right, so I would probably just use this one. I'm sure that you could have used the bar diagram, but I would probably just use this one. All right, now it says solve rate problems. You can use double number lines or equations to solve rate problems. So now it says the Millers drove 105 miles, so 105 miles, on 4 gallons of gas. At this rate, how many miles can they drive on, let's try that again, 4 gallons of gas, 6 gallons of gas. So if we have 105 miles on 4 gallons, how far can they drive on 6? So as you can see, they went ahead and divided 105 by 4 to get the unit rate. So for every 1 gallon, they drive 26.25 miles. So 26.25 is equal to 1 gallon. Now you just take the 26.25 and you can multiply that by 6 and you get 157.5. So they want you to fill in the double number line just like I've done here. So see the box just above the 1? That's where you would put the 26.25 and then you would put 157.5. Now the interesting thing, remember I told you when we solved unit rate problems before, is that once you find the unit rate, you can find anything. So let's just do a little quick test for that and let's see if we can figure out how far we can go on 3 gallons. So now we can just take 26.25 and we can multiply it by 3. So I've done the multiplication off to the left here, and you can see that we would go 78.75 miles. So we could make our own little box right here if we wanted to and say that. And that was just to remind you that once you find the unit rate, you can find anything. All right, go ahead and pause the video and see what you can do with C. All right, great. So now what I've done here is I've drawn a double number line like they did, and I've used the bottom to represent scoops. And what they told us was that there's 810 calories in 3 scoops. So let's go ahead and write that on our double number line. And just like they did, I'm going to add a block there at 1 for our unit rate, and I'm going to add a block at 7 for our answer. So the first thing we need to do is find the unit rate. We find the unit rate by taking the 810 that we know about, divided by the 3 scoops that are in it, and go ahead and divide that out. So we got 3 times 2 is 6. We get 2 left over, drop down on the 1. 7 times 3 is 21. And you get 0 here, but remember you have to drop that second 0. And just like I've always taught you, when you have that double 0 right here, see that double 0? I've also called that snake eyes before. You want to make sure that your 0 goes in the quotient. So now we know that each scoop is 270 calories. So we're going to put that 270 right there in the 1. So now we can take the 270 and we can multiply it by 7 because we need to find out how many 7 scoops is. And now we can see that it's 1,890 calories. So we're going to go ahead and put 1,890 calories right here. And then we're also going to write that answer on our line up here. All right, great. So let's go on and see what's on textbook page 74. Textbook page 74, example 4 says, Jeremy drove his motorcycle 120 miles in 3 hours. So let's go ahead and put a box or a circle around that. At this rate, how many miles can he drive in 5 hours? At what rate did he drive his motorcycle? So there are actually two questions here. So the first thing that we need to do is go ahead and set our problem up as a rate. Not a unit rate yet, a rate with the information that they gave us. Now it says at this rate, how many miles can he drive in 5 hours? So because I'm going to have to find 1 hour, I'm going to put hours on the bottom. So let's go ahead and look at that. So we first start with 120 miles over 3 hours. Now we know that we need to get to 1 hour to find a unit rate. So we ask ourselves, how do we get from 3 to 1 using only multiplication or division? Well, 3 divided by 3 is equal to 1. So now we're going to do that on the top as well, divided by 3. 120 divided by 3 gives you 40. So now we find out that he goes 40 miles in 1 hour. Okay, so now we can take that information and we can find out how far he goes in 5 hours. So we'll take our 40 miles in 1 hour and multiply it by 5 hours. 5 times 0 is 0, 5 times 4 is 20. So now we find out that he goes 200 miles in 5 hours. So now we can see our answer. So Jeremy could drive 200 miles in 5 hours, driving at a rate of 40 miles per hour. So that's where they got the 40 miles per hour, and this is where they got the 200. All right, awesome. We are on D now. It says, while resting, a human takes about 5 liters of air in 30 seconds. You want to pause the video now and go ahead and try this on your own. All right, welcome back. It says, at this rate, how many liters of air does he take in 150 seconds? Well, since it's asking us about 150 seconds at the end, that means seconds has to go on the bottom. So let's put 30 seconds right down here. And the reason it has to go on the bottom, remember, is because we're going to be getting it to be 1, because we need to find out per second first. Whoops. And then we can go ahead and multiply it out by 150. So we have 5 liters in 30 seconds. So then we ask ourselves, how do we get from 30 to 1 using only multiplication or division? Now, don't get crazy just because you're looking ahead and going, oh my gosh, I don't know how to do this. You have to still follow the process. So 30 divided by 30 is going to give you 1. So now up here, we need to do 5 divided by 30. So let's go ahead and do that math. Now you want to make sure that you set this up correctly. So 5 divided by 30. Keep in mind, because your number is going to be less than 1 because you have 5, which is small, and you're dividing it into 30. So your answer will be less than 1. So remember, when we do that division, you're going to go 0, decimal, decimal, 0. Okay, and that's because 30, you can't divide 5 into 30 right away. So now we can go, okay, 30 goes into 50 once. So we're going to put our 1 here. 30, we get 20 left over. We can add another 0, drop it down. Now it's going to go in 6 times 3 is 18, so we get 180. 20 left over, drop the 0. Now this is just going to repeat. So now we need to think of a new strategy because that one's not really going to be very advantageous for us. So let's look back at the problem and our numbers. We have 30 seconds and what we're trying to get to is 150 seconds. So we've missed something obvious. And I do this on purpose so that you can see that when you make mistakes, you just have to go back through and you can rework the problem. So you want to go ahead and erase the information there. And now let's think about it. We can get from 30 to 150 pretty easily, right? So this is one where we don't have to find a unit rate first. So now let's go 30 to 150. How do I get there? Well, I multiply by 5. So then on top, guess what? I multiply by 5. 5 times 5 is 25. So that means the average human is going to take in 25 liters in 150 seconds. So see, you had to find a different strategy because you were going to come out with some crazy decimal when you tried the unit rate. So you have to be flexible in your problem solving ability. All right, so now you have made it to the guided practice. Yay! All right, so now all you need to do is numbers 1 through 3. You want to make sure that you show all of your work. If you need some extra room, use your line stickies as well. And make sure your final answers have units. So I need to know, are we talking about dogs, unicorns, ponies? What are we talking about here? So 1 through 3, and then I've got this cute little picture here that says, I don't want a math, I want a coloring book and a juice box. You? Anyone? All right, I'll see you next class period.